It's the Advent of Code live stream. Hi everyone. I'm going to look at today's Advent of Code and solve it in Lamdu to demonstrate how to use Lamdu. So to not bore you, as usual, we're going to start with copying the input and parsing it into Lamdu. This was yesterday's solution. Let's close it and open a new repo and paste the input. And what are we doing with this input? It looks like a maze with this start and end in capital letters in bold. Okay. First, I know for sure we should split on lines. And after that, I'm not sure. Okay, it is a maze. We reach the path in a certain number of steps. Let's read. Okay, these are elevations from A to Z. Okay, so let's parse it. We want the characters, and we will want to map those. And if character equals S, then this is start. And if it's equals capital E, then it's end. Oh, my face is in the way. Sorry. Yes. So start. Otherwise, no, end. And yeah. Otherwise, it's normal, I guess I'll call it. With we'll take. I'll make my face smaller as well and put it here. We'll take the code point of the character, and do we count elevations from 0? They're not. I guess they're not really counting elevations as numbers. I don't know. Okay, so we just cannot climb too much. Right, at most one higher. So let's make the minimum elevation as a number 0. All right, and let's collect this into an array and collect this into an array. Right. And let's call this Advent 11 example. Input, Advent 12, sorry. We already had Advent 11 example input. Let's take this into a let item. And we can call this, let's make it an input of this. So one way to do it is actually, well, the easiest way I guess is to add an input here and use it. And we can call it parse advent 12. Yeah, we can parse advent 12 of advent 12, for example, input. We can extract it to a global and bring it out of the way, right? So we have this array. And so I guess we need to do Dijkstra's algorithm here of shortest path. Or, you know, a more fancy one like A star. But Dijkstra would do it. Now, we don't have it in the standard library. So we actually have to implement Dijkstra's today, which is nice. So let's see. What is, let's call it shortest path. Well, let's call it shortest path. We probably have an initial. We have neighbors, I guess, or destinations. Or maybe we would call it edges. And yeah, and we have a destination as well. Right. And should I use the mutable subset of Lamdu here? Yeah, well, I think we might be coding mutable binary heap. The one thing is we don't have a do notation syntax sugar yet, like Haskell. Yeah, and so I guess if I want to make it generic, then I would want to make like a search tree for let's try to make a functional variant, I guess, of Dijkstra here. So let's start. And I guess we don't actually need the whole shortest path. We just need its length. So let's not make it shortest path length. And let's call it short path length. Yeah. So we are going to have a loop, and we're going to start with a state of next node to evaluate will be the initial. Done nodes, right? And I'll make it into an empty list. And yeah, we have like a queue of upcoming places we can go, which also would start as empty. And we are looking at the edges of from the next number. Oh, you know what? Instead of next, sorry, we shouldn't have next. We should have it in the queue, right? So the queue is not an empty list; it's the initial one here, right? But it's also with length. So it's a record. Length is 0, and node is the initial node. Right. And we are going to find the minimum. We actually want the minimum on kind of function. So let's make a minimum operator. Like there would be a list, there will be key or on. I don't know. Key is how it's called in Python. Sort on is in Haskell. Sort on. Let's do this for now. So we'll do a simple fold. Yeah, and we will start with nothing. We'll fold over the list, and let's pattern match on the accumulator in case of nothing. And you know what? Yeah, in case of nothing, then the answer is just. And going to do result is the item, and the key, I guess, is on item. In this case, we're going to calculate on item. I guess we calculate it anyhow, so let's put it outside and call it key. Right. So so now we have it, and we just compare. If key 1 is smaller than key 0, then this is the result. So also we can Yeah. By the way, we know the answer is going to be just always, actually. So let's take it outside. Um, yeah, let's take it outside here. Just, um, let's extract this and put it just over here. And then not put it here. And yeah. And then in the other case, it's this record, and in this case, let's take this here and call it well, I call it current. The current is the minimum. Okay, so we have this min on function, should work, and I'm going to take the minimum from the queue. Yeah, I guess we may want to extract it from the queue as well. So let's open it. Oh, yeah, we should improve our go to who here to maybe show the type of the symbol involved. Yeah, so let's actually not do min on, it's not what we want to do. Let's do extract min. Or I guess there's no good way to extract it other than finding the minimum and then extracting it. Okay, so okay, so let's find the minimum. Yeah, minimum of the queue on the length of the path to it so far. Right, and yeah, it should be a just. So let's ignore the nothing case. Right. And if this is if record, yeah, if the node is the destination, then we're done. Yeah, then our answer is just len 0. Otherwise, we do stuff. Yeah. So otherwise, we add. Otherwise, we resume in the loop, can't, with. We add the current node to done. And now to the queue, we add the next destinations. Let's start filtering from the queue the current node. Node 2 isn't node 0. Right, and we can call I guess because it's automatically given name field name, like to give it a name, I can do like a let item current equals node 0, and I guess is this more readable like this if current equals destination? I don't know. Anyhow, so we have these, and we add the edges from the current node, which we map over, which we, I guess, first filter over to see that they are not in done. We need to make a member function, member. Should the list be on the left side or on the right side? Let's take the list on the left and the item on the right. I don't know. It's a matter of style. I guess it should be the other way around. Let's move item to the left and still make it an operator. So you don't really need to commit to it like in Haskell. We don't do currying. It's keyword-based arguments. So we can play with the order, and it doesn't affect user code like it would look in the new way. So I guess we don't have it because it's so simple to produce in terms of any of. So let's undo. I don't need the member function. Yeah, I was going to code it. Yeah, any of, and then it's kind of expected what equals what. Node any of done. Any of done, x equals node 3. Not any of. So actually, let's do all of, right? Done. All of x, like node 3 isn't x. Yeah. Okay, so we filtered over the target edges. Now we map over them to put them in the queue form, which the node is so what does edges produce? Yeah, this is the first time we're using it. So the node is record dot node, and the length is len 0 plus the length of the node, record dot len. Yeah, we should have the extra now, I guess. So let's try to use it. Short path len, and in it we'll be looking for the place in the array which has the s. So we'll use coordinates. So let's try to find let's start by finding the initial place. And you know what? Instead of dest, we don't want a dest. We'll make dest into a test. So if dest node, then we don't have to check beforehand where the end is. Okay. So let's iterate over all the rows. Or actually let's iterate them over them like this. From array R, and I will zip it with indexes, not 0 to, well, I can do 0 to len R, I guess. I can also do iterate 0, num plus 1, and ignore the tail. Well, I guess we don't need to do it. Let's iterate over the rows. Length of R. And let's map it and also iterate over the columns. Length of R at 0, and I'll map over this and produce a record of row is, let's call num0 row, or line, let's call it line, and line is line, and then the other would be column, which we can abbreviate as call. Let's close the shortest that. And let's call this number call as well. Yeah, right. And let's concatenate that. And these are like the indices. And let's find the first of the indices, which are at line at call equals s. No, not s. This is parsed now. Equals start. Yes, and it's the top left. And let's pattern match on the maybe, because we know it's going to be the answer. Right. Okay, now I can do the shortest path length from this. Yeah. Right. And the destination function will be if r at line at call equals end. This checks for the destination. And the edges, I guess we can go in 4 directions. Right, let's make the directions deers. Yeah, so we're going to have literal arrays in the future, and then this would be nicer, but currently we have no syntax trigger for that. So I'm doing the deltas for the directions, right? So it's going to look kind of more like a Python list in the future, but it will be an array rather than the equivalent of a Haskell linked list. So actually, in one of the previous advent of code, we had like this go function. There we made it x and y. Okay, so let's map over the directions and have our like current position will be line is line 2 plus line 3, and column is column 2 plus column 3. And we are going to okay, let's filter over those, sorry. Yeah, I'm going to filter over these, and then after we filter over them, we will map over them as well. So I'm going to filter over them. So line 4 is bigger or equals to 0, and also let's call this length of our 0 width, and I guess we can call this height of the map, right? So line 4 is smaller than height, and column 4 is bigger or equals than 0, and col 4 is smaller than width. Okay, so actually all edges are the same, so I'm using length of 1, and yeah, and this is just the, oh, no, we have another condition, but basically, yeah, let's add the other condition. And so let's have a function to get the elevation, right? Elevation of line and column is we'll take the array at line and at the column and we will pattern match over it. Yes, if it's the start, the elevation is 0. Or actually, yeah, if it's normal, then this is just the elevation. Let's turn off the value annotation. We have and if it's the end, it's I don't remember what is how many letters are in the English alphabet. So it's code point of Z minus code point of A. Right. So we are going to check the elevation of the current position, and the condition here is the elevation of this position and is smaller or equal than the current elevation plus 1. Yeah. Now with this condition, this is just place, and I think we may be done here. Just let's extract this, call it advent 12, make it take an input, parse this input. We can use it in a new repo, sorry. Advent 12, example input, let's see. Okay, reach the hole, cool. So we reached an empty queue in our shortest path. So we can follow, we started with the first one, then it was marked as done. Then the queue had it again. It's funny. So let's see, how did we continue? We marked it as done, and we filter. Yeah, looks like this is our not equals to is faulty. This is the big bug in Lamdu. But we are inheriting we compiled the JavaScript, and I guess the JavaScript equal, non-equal then is faulty. Let's try. Let's see if equal then is good. Not node 0 equals node 2. Is it the same? Oh, sorry. Was it false before, actually? Did I blame the wrong thing? Yeah, no, it's right. It's not equal then. Okay. So filter, and the filter was empty. That's good. Then the edges return the same node again. That's not right. Yeah, no, it's not right. So we have a problem in our nodes function. Sorry, I want to open this. Sorry, it's the wrong record here. I want this one. Yeah, and the answer is 27. Is it the answer in this case? No, it says the path reaches the goal in 31 steps. Huh. Yeah. I guess if my Dijkstra outputted the path, it would have been helpful to debug this, huh? So the first one was, let's look at what the minimum was. Right? So first one is 0, 0. Then it was 1, 0. That's right. Then it says we reached 2, 0 because why not? And the length was 2. Then all of these are A's, right? Okay. So then 3, 1. Wait. 3. Oh, 4, 1, and then 3, 1. So we should have tested this B and this A before. Well, we should tested 0, 1 instead of before of 2, 0. How did we not? So when we did 0, 0, our neighbors were 1, 0, and 0, 1, right? And we added them to the queue. Oh. Wait, right, they're both at the queue, and both are with len 1. Fine. Then at the next step, funny, our queue min thing is incorrect. How is it incorrect? Because I did this incorrectly. I did it incorrectly. Which rec is this? Okay. If the accumulator is better, then it's the accumulator, sorry. Otherwise, it's the current one. Yeah, just mix things up. Okay. So now the answer, it's also shouldn't be 7. So let's look at the shortest path order of nodes again. 0, 0, 0, 1, 1, 0. Yeah, this is good. 1, 1 was the next to test. Why not? 2, 0, 0, 2. Okay. 0, 3. Sure. 1, 2. 3, 0. So 7 looks like if we wouldn't filter anything. So we have a problem with the comparison of the heights. I'm checking the wrong nodes elevation. So 31, yeah, that's the answer. Cool. So we have this. Let's see with our own input. Now I did a very inefficient Dijkstra here, so let's see. Advent 12, my input. Because ideally I would I wouldn't do a linear search for a minimum. We'll see. We may have to make it more efficient. We could use a binary heap for the queue. We're still polynomial time. It just is a big input. Yeah. So As I was saying, Lamdu is currently compiling to JavaScript, and we run a sub-process of Node, and it's not super fast. Another algorithmic thing we can do is use A star instead of Dijkstra to make us skip a lot of paths that are getting, not skip, but defer testing further paths that are getting further away from the destination according to the Manhattan distance. Yeah. So it's churning at 100% CPU. It's keeping busy. It's going to be complexity squared to the number of nodes, or it should be n log n with the heap. Okay. People are early in the office today.
17.3 kilometers per hour.
Okay, I guess this is too boring. Let's abort it and make an efficient computation of Dijkstra's algorithm using Lamdu's is it still churning? Alright, no, it did kill the sub-process. Yeah, so let's try to make a more efficient, shortest path length. And let's make it use node index function in num nodes. Right. So we're going to do this differently now. So let's make a new array. So we're going to run a mutable process now. Right, in this mutable process, we're going to start with so this is how we do mutable processes. We put them in a sum type. Let me take my head out of the way. Oh, I'm not in the window. To array, no, I want to make a new array with stuff in it. we have an array from. Well, let's start with a new array. We call it done. And let's iterate over all the num nodes. 0 to num nodes, sorry, I'm 4, and we append to done false. All right, all the items are not done. Now, in this case, we know that okay, let's make a queue and make it just indexed by the score. So let's make another new array. We'll call this one Q. And I guess we do that before this, and we append to it in the same loop. So let's we have new array done, we have new array Q, and we also append to the queue the empty list. Now we do append to the queue the initial node. Right. So how do I modify the item in array? Right to array to the queue at index 0. I will have a list of the initial node. Right. Now let's loop with the currently best score. Let's read. red items in the queue. And fold over them. If the item is the destination, we are done. Huh. Crashed. We didn't have completions. I should move. So this is the most serious bug found in Lamdu in the live streams so far. Sorry, let's make it in the right size. Yeah. So what did I do? I did if boolean. Then over here, I just wanted to return nothing. Let's try to type it here. Return nothing, right? This, no reason why it couldn't be this action. Huh. Oh my God. I will have to debug this, but I guess I can't do it in the live stream. But this is part of why we're doing it. So yeah, cursor is undo menu prefix, but not on search term or any result. So there's quite a lot in Lamdu we made our own UI framework to support all of the keyboard-based editing and animations and responsive layout. And we may have bugs. So I'm doing this to catch them. So I will debug it offline and post my solution when it's done. So hope for a more successful attempt at tomorrow's advent of code. Yeah. Bye.